This is Geometry, Unit 10. We're working on 3D and 2D relationships. A polyhedron is a solid that is bound by polygons and enclosed a single region of space. So I often like to think about it as a fish tank. That would be a polyhedron. All the sides are polygons. If the sides are not polygons, like down here, some of these sides or none of these sides are polygons. So this is not going to be a polyhedron. And plural would be polyhedra. A base is a polygon that is used to name the polyhedron. There are always less bases than there are faces or sides. Bases and faces. The base is the shape that's being repeated throughout the entire figure. And the sides, in this case, is a rectangle. And you can tell that it's not really repeated throughout the whole shape. It kind of moves all over the place. But this hexagon is a hexagon on the top, it's a hexagon in the middle, it's a hexagon towards the bottom, it's a hexagon on the bottom, all the way through. So that's how we would name it as a base. So we have different types of polyhedron. Here we have a pyramid. A pyramid comes up to a point, and we name this pyramid by the type of base that it has. So this is a square. We call it a square pyramid. A pyramid comes to a single point. It's not the same square all the way up. But if you were to cut it here in the middle, you would see another square. And if you would cut it towards the top, you'd see another little square. But then you go up to the tip top, and it's a point. The other faces that are making up a pyramid would be considered what? We have the square for the base. Take a look at what's making up a pyramid. What are the faces? What are the sides made up of? Triangles. The other faces are triangles. That's what really defines it as being a pyramid. You have a base. It might be a square. It might be a rectangle. It could even be a pentagon or a hexagon. It could be any shape, any polygon. It could even be a square or a triangle. Over here, this one's a different type of shape. Notice this is not a pyramid. The base is not continually going up to a single point. It has the floor, and then in the middle it's a pentagon, and in the top it's a pentagon. So the floor and the ceiling are both pentagons. It doesn't matter if you're standing on it. If you turn it sideways, those pentagons, they're still considered to be the bases. Bases do not have to be what it stands on. It's the shape that's being repeated throughout the entire figure. All right, so if this is going to be considered a prism, and it's made of a base on bottom, in this case it's a pentagon on bottom, what are the sides made up of? squares, we'll call those rectangles because it all has to do with how tall it is, but rectangles. Okay, sides are typically rectangles when we're working with a prism. So, shapes that are not polyhedron, polyhedra. This would be a cone. A cone has a circle for a base, and then it goes up to a point. This is like a ball, soccer ball, baseball, tennis ball, golf ball, whatever creativity we want there. In geometry, we call it a sphere. And then this can of soup, what would we call that? What shape would that be? Cylinder. A cylinder is made up of a circle for a base. It would be a circle in the middle. It would be a circle at the top. It is still a cylinder if it's on the side. It still has bases that are circles, even if it's on its side. So the shape does not have to stand on its base. So we're going to determine what type of shape we have. We're going to name this. Is it a polyhedron? Yeah. Okay, it has polygons for sides. So what type of polyhedron is it? We have two different types of polyhedron. We have prisms and pyramids. So this falls underneath the pyramid, of course, because the sides are triangles. It goes up to a point. What shape is the base? It has 6 sides to it, so it's called a hexagon. So we're going to call this a hexagonal pyramid. Hexagonal pyramid, because we name the pyramid by the type of base. It could be a hexagon, it could be any polygon. It's a pyramid because the sides are triangles and they all go up to a point. Okay, what would we call the next one? A prism. A prism has bases, polygons for bases, and the sides are all rectangles. Well, here we have rectangles for sides, or you could turn it around and you have the longer ones as sides. So it really wouldn't matter how you turn it. It's the same name either way you think about it. Rectangular prism. How about this one? Does this fall under a polyhedron? Because it's curved, because it has a half cylinder in it, it is not a polyhedron. Because of the half cylinder, this is not a polyhedron. All right, now let's be careful about this one. This is the common one that people have trouble naming. What might this one be called? Looks like a slice of cheese. That's not going to get you very far. Okay, a triangular pyramid. Okay, pyramid is the common mistake to call this one. Notice that the sides are coming up and they're touching at a long edge. Is there a polygon that's being repeated throughout this whole shape? You see this triangle here. There's a triangle. In the middle, we have the same triangle. At the end, in the back, we have the same triangle. So the triangle shape is being repeated all the way through the shape. What are the other sides? If the orange is laid out as a triangles, what are the other sides? The rectangle are the sides, and the triangles are the base. So this is a triangular prism. Okay, how about this one? Not polyhedron. What shape is it called? This would be a cylinder, a can of soup. Okay, can of soup would be an improper name if that's what you were trying to do on a final exam, right? It is a cylinder. Okay, last one. Okay, what type of pyramid do we call it? What is the shape of the base? It is a rectangle, so a rectangular. A rectangular pyramid. The sides are made up of triangles, and the base is the rectangle, rectangular pyramid. When we talk about cross-section is when we take a polyhedron, and it doesn't have to be a polyhedron, and we take a solid and we slice it into two pieces. And the cross-section is the stamp portion. It's not one of the chunks, but it is just the polygon that's being formed through the plane that's cutting it. So this would be a triangular. A triangle would be the cross-section. A cross-section is an intersection of a plane and a solid. Okay, what type of pyramid would we call this? A triangular pyramid. Does anyone know the other name for a triangular pyramid, a four-sided figure? A dice has 6 sides to it. This has 4 sides to it. So it is called a tetrahedron. Okay? Tetrahedron has our 4 sides. Okay, our cross section. Here we're taking this, we're slicing it through, so what we're looking for is the shape of the stamp that would be formed. We're not looking at the dome. We're just looking at the two-dimensional shape. What shape would that be? Be a circle. What's the cross section here? Pentagon. Now here's a bit of a trick one. If you were to tell me you were doing a cross section of a cylinder, I would just imagine that you were doing a cross section and you would create a circle. But notice, if you are perpendicular to the bases, you're not creating the shape of the base. So what's the cross section of this cylinder perpendicular to the bases? A rectangle. And this is a pentagonal pyramid or prism. And we're doing a cross section parallel to the bases. So we are creating the pentagon again. It's like a slice of bread. And slicing it down parallel to the bases, we're going to create the pentagon. So what we're noticing, what we've talked about, is that if you do a cross section parallel to the base, then you're going to create the base. Okay, if you do a cross section perpendicular to the base, you often create a rectangle. Okay, what do you notice about the shape of the cross section when it's parallel to the base? The cross section parallel to the base will create the base shape. The base's shape. Okay. All right. Last little section that we're talking about. So here, we're going to stick this sticky note acting as a y-axis, and we're going to spin it around in circles, and we're trying to imagine what shape that we are creating. If you notice, this corner is going around in circles. This corner is going around in circles. So if we were to draw that out, be something like that. So what are we creating when we take a rectangle and we rotate it around the y-axis? We created a cylinder. And if we take our sticky note and we're going to create a triangle of sorts out of it. Okay. And if we take that and rotate it around the x-axis, what shape would we create? This edge would come out and B would create a circle. This part would spin around and come to a point. So we have a cone. So a triangle rotated around an axis is going to create a cone. A circle, even a hemisphere, well, that's a three-dimensional shape, I guess. Even half our circle spun around an axis. What shape would that create? If this edge came out, went back and around, we'd have a sphere.